Okay, so let's talk about a problem that, let's be honest, every single one of us in the data world hits eventually. What do you do when your data just gets too big for your laptop? Well, today we're going to dive into PySpark, a tool that doesn't just solve that problem, it completely changes the game.
Right. If you work with data in Python, I'm willing to bet you have seen this. It's that awful sinking feeling, you know? Your script is chugging along and then, bam, it just hits a wall. A very specific and oh so frustrating wall.
And there it is, the dreaded memory error. It's basically your computer's way of throwing its hands up and saying, nope, I'm done. Your ambition has officially outgrown my RAM. So what's the solution? How do we get past this? Well, the answer isn't to just keep trying to buy a bigger and bigger computer. The real solution is to start thinking differently. Instead of one giant machine, what if we could use lots of computers all working together? This is called distributed computing, and it is the absolute core concept behind a technology called Apache Spark. I love this quote because it makes it so simple. Spark essentially lets you walk into a room full of regular computers, link them all together, and command them to act as one single, super powerful machine. Just think about that for a second. The power you'd have at your fingertips is incredible. So how does Spark organize all these computers? Well, it uses an architecture that you can think of like a manager and their team. It's often called a driver-worker architecture. And the whole workflow is actually really intuitive. It works like this. You hand your code, your big project, to the driver. The driver is the manager. It looks at your project, breaks it down into a bunch of smaller, manageable tasks, and then it goes to a cluster manager to get the resources, the team members it needs. Finally, it hands out those small tasks to its team of workers, who do all the heavy lifting in parallel. Okay, so this powerful distributed engine is great and all, but you're a Python developer, right? How do you actually talk to it? How do you control it? That is exactly where PySpark comes in. Think of PySpark as the ultimate translator. It's the bridge that lets you write the Python code you already know and love, and it translates that into commands for the entire powerful Spark cluster. And here's the best part. You're not getting some watered-down light version. Nope. PySpark gives you access to the whole shebang, the full suite of Spark's incredibly powerful features, from SQL and data frames to machine learning and streaming. So, what makes this whole system so unbelievably fast? I mean, really, what's the secret sauce? It actually comes down to two kind of magical core concepts. First up is in-memory computation. See, older systems like Hadoop, MapReduce were constantly reading and writing data to the physical hard drive between every single step, and hard drives are slow. Spark, on the other hand, tries to do as much work as possible in RAM, in memory, and that is dramatically, unbelievably faster. The second feature, and honestly, this one is just plain clever, is something called lazy evaluation. The best way to think about it is like a chef who's writing down a recipe. You tell Spark, okay, first filter some rows. Spark just nods and writes that down. Then you say, next, add a new column. Spark just writes that down too. It hasn't actually cooked anything yet. It's just building a plan. It's only when you finally say, action, show me the result, that Spark looks at the entire recipe, optimizes the heck out of it, and then executes everything all at once in the most efficient way possible. It's lazy in a brilliant way. So all this theory is great, but let's get down to brass tacks. What does the code actually look like? Is this going to be a massive learning curve for someone who's used to, say, pandas? Let's take a look. Okay, look at this. Filtering a data frame. In pandas, you use the classic bracket notation. In PySpark, you use a dot filter method. But the logic inside, it's identical. That feels really natural, right? How about selecting columns? Again, it is so similar. It's this familiarity that makes the jump from analyzing data on your laptop to analyzing massive data sets on a cluster feel, well, not like a jump at all. It's more like a small step. And even for something a bit more complex like grouping data, you can see the parallels. The core ideas, the syntax, it all remains incredibly intuitive for a Python user. But here's the thing. PySpark is so much more than just a pandas for big data. It lets you perform really sophisticated analyses that would be a huge headache to do otherwise. Let's think about a really common business question. A question that sounds simple, but is actually pretty tricky to answer with a lot of traditional tools. So imagine you've got a table of data that looks something like this. You've got product revenues, but they're all mixed together in different categories. Now, the solution in PySpark is, Well, it's just beautiful. It uses a powerful feature called a window function. This one line of code is telling Spark, hey, I want you to rank my products by revenue, but I want you to do it in separate windows. Partition by category means treat the toy category as one group and the snack category as a completely separate group. And boom, here's the result. Look at that rank column. It ranks the toys 1, 2, 3, and then when it gets to the snack category, it starts over again at 1. With just one elegant command, we've solved a really complex grouped analysis problem. This is where PySpark goes from being a tool for big data to a tool for deep, powerful analytics. So think about where we started. We went from a frustrating memory error to effortlessly solving a complex analytical question on a huge data set. The real takeaway here isn't just that PySpark lets you handle big data, it's that it unlocks the ability to ask bigger, better, more interesting questions.